Hello everyone, my name is Devashish Roy. I'm the head of training and development at the Indian Cybersecurity Solutions, and I welcome you all today. This webinar and today's topic is a very important one for your enterprise networking, that is MPLS fundamentals, that is multi-protocol label switching, and L3VPN overview. So there is VPN, virtual private network for your security, that is a WAN technology, and we have L2VPN as well as L3VPN. So L3VPN is something that is only the theory part is there in your enterprise examination, that is in the NRC and NCORE, because the practical part is a huge one. It covers all the VRF, everything, virtual router and forwarding, even the MP-BGP, multi-protocol BGP, all these things. So we have to know only the theory part for your NRC and NCORE certifications. So first begin with MPLS and then we'll move to the L3VPN part. So we'll talk about the MPLS fundamentals and L3VPN overview, and we will go into in-depth understanding and we'll explore the concept, that is multi-protocol label switching and layer 3 virtual private networks. So what is MPLS, multi-protocol label switching? So it is a switching format. So switching technology, like we have the circuit switching, like the ISDN we had, means you can connect and disconnect the circuit in the circuit switching. Whenever it is an on demand, means whenever you are going to use it, you want to connect, you do not want to use it, you just disconnect. That is the circuit switching. The cost is low. Then you have the packet switching, like the data is traveled by the packets. So it is like the packet switching means the frame relay network we had. But nowadays we do not have frame relay anymore. So nowadays we come across only the label switching. So label switching means you are actually labeling the packets. You are marking the packets. So that is the main part of MPLS. So MPLS optimizes routing efficiency by actually utilizing labels to make data forwarding decisions. So you are making some numbering. Labeling means what? You are numbering the data. Let's say 100, 200, like that. You can give a range. You can give explicitly a range, or else it will take a label, that also can be. So rather than relying solely on complex network addresses, means IP address, it is relying on labels. This technique enhances speed, allows for the traffic management, and supports various networking protocols. So why multi-protocol? Means it supports a lot of protocol, lot of routing protocols. That is why it is multi-protocol label switching. Now, MPLS is a networking technique that enhances the performance of data transmission over packet switch networks. So in case of packet switch, means frame relay, we have the dedicated virtual circuit, like the permanent virtual circuit or switch virtual circuit, that was temporary, but it was not so efficient because it was a shared network. The frame relay wasn't a dedicated network like the VPN, like the lease line. No, it was a shared network, and the bandwidth was also low. But MPLS achieves this by using labels to make forwarding decisions. It achieves speed and enables efficient traffic management and improved bandwidth utilization. Because before the automation came, the MPLS was the backbone of data transfer. And still, even in the event of the automation, you have the MPLS technology that is there. That is there in the, say, the broadband, the traditional broadband, that is also there. The VPN is also there. But MPLS is also here as the backbone of the, you can say, the data plane, the data transfer. Now, there are some key components of MPLS that we must understand. First of all, LER, Label Edge Router. Now, Label Edge Router, it serves as the entry and exit point for MPLS packets. So you can say that is a customer premise router, or you can say this is actually my device or customer device. So the packets are entering and exiting the customer network through the LER, and it facilitates communication between the MPLS network and external network. So they play a crucial role in the labeling process to ensure actually packets are properly routed within the MPLS framework. So They are responsible for marking the packet with label. They are the first one responsible. Then comes label switch router, LSR. So what is the job of LSR? LSR are responsible for forwarding packets based on the labels assigned to them. So they switch the label. They actually swap the label. We call that swapping. So what is there, like in LSR, they are responsible for forwarding packets. They see the label and they swap the label. They change the label. They are integral to the MPLS architecture, and as they facilitate efficient data transmission by quickly switching packets without examining the entirety of headers. So MPLS has some complex headers, like in the VPN GRE that we'll talk about later. You have one outer header, one inner header, and MPLS also, it is a layer 2.5 technology, we say, and that is between the data link and network header. So label switch router, without looking at those headers, they simply forward the packet based on the labels. Now let's talk about label distribution protocol, or LDP. LDP is essential for the distribution of labels within the MPLS network. So the protocol that is inside the MPLS, that is LDP. LDP is responsible for your label distribution. It enables LSRs to communicate label mappings to ensure that packets are appropriately forwarded across networks. So in one router, say that is outer one, so there is another label like label 100. You are forwarding the packet to router 2, then the label changes to swaps to 200. Who does that? Who manages that? LDP, thereby optimizing performance and ensuring that seamless data flow is there. So in the data plane, who is working behind the MPLS data transfer? LDP. Now let's talk about MPLS architecture a bit. So we'll understand the flow and processing of data in MPLS networks now. First of all, data flow. Data travels in MPLS by being encapsulated in packets that include a label. And the label guides the data through various network nodes. Nodes means here in this case the server, the router, ensures efficient routing based on predefined paths. So definitely we have determined or predefined some paths with the routing protocol. And as I've already told you, MPLS is mainly working on BGP, border gateway protocol, because you configure this with between the customer and the ISP. But you can have other protocols like OSPF also, or EIGRP. Second is label assignment. In MPLS, label assignment occurs when a label edge router, LER, assigns labels to packets that I've already told you as they enter the MPLS domain. So this is the first one. And this process utilizes protocols like LDP to ensure that each packet receives a unique label. Then comes forwarding. Once labeled, the packets are then forwarded through the MPLS network via label switch router, LSR. So the label is actually there, it is marked first, then it is forwarded. These routers make forwarding decisions based on the labels. So they do not have the routing table. That is a label information base, LIB, or LFIB, label forwarding information base. So a lot of things are there in the MPLS. So not in, it is the RIB or the routing information base, it is based on the label information base, enabling rapid and efficient data transmission across the network. So that is about the MPLS. And what are the benefits of MPLS? Optimized bandwidth utilization, reduce latency because it's fast, enhanced security features, and improved fault tolerance. Now we'll talk about the L3 VPN, that is very related to this MPLS, because often we configure layer 3 VPN over the MPLS. But the thing is that layer 3 VPN is a big thing. It is not only the IPsec VPN or the GRE tunnel GRE VPN that we configure. It is a layer 3 VPN that is meant, that is established over the MPLS architecture. So you have the MPLS, and over that you have the VPN. So L3VPN, layer 3 virtual private network, enables secure and private data communication over a shared network infrastructure. Now it operates at the network layer. That is why it is known as L3VPN. Allows multiple customer networks to coexist, while maintaining data isolation and security. So what are the L3 VPN concepts or terminology? First of all, that I've already told you, VRF, virtual routing and forwarding. This is a very important core concept of L3 VPN. Now, what does it mean? It enables the segregation of customer traffic by allowing multiple instances of routing table to exist on the same router. So it is actually saying that you have one routing table, but you are logically dividing the routing table into multiple parts or multiple instances, because say two companies are sharing the same routing table, say the ICSS and the Cisco, they are sharing the same routing table or the same address space, rather, say the 10.10.0.0 network. So what will happen? Definitely there should be two separate routing tables, but I have only one. So what should I do? On one router, can there be two routing tables? No. But I can logically separate the routing table into two parts. That is VRF. And it ensures that data paths remain isolated and secure. Then comes customer edge, CE router, that I was talking about. The customer edge router is positioned at the customer premise and it serves as the entry point to the service provider's network. So I'm the customer. So my router is a customer edge router and I'm connected to the provider router. So it is responsible for interfacing with the customer's local network, and then it forwards traffic to the provider edge device and then to the main site, that is the provide network. Then the provider edge, PE. Provider edge router is located at the service provider site and plays a crucial role in actually connecting customer networks to the provider's MPLS backbone. So the service provider is responsible for giving you the MPLS, but your provider edge router should be connected via MPLS to the provider. It manages the routing of traffic between different VRFs and ensures that secure and efficient data transmission is achieved. Now, how L3VPN works, we should understand the traffic. First of all, traffic entry. The customer traffic enters the customer edge CE device where it is prepared for forwarding. So the same way it follows like the MPLS, first the CE, then forwarding to provider edge. The CE device forwards the traffic to the provider edge PE device, establishing the connection to the provider network. So PE is the first point of the provider network. Then MPLS routing. P device utilizes MPLS technology to efficiently route traffic through the provider's backbone network, ensures that optimal performance and reliability is achieved. So there comes the MPLS part. So first this L3VPN, but it is actually utilizing MPLS routing. So what is the benefit of L3VPN we have? We have flexible network architecture, enhanced privacy features, support for multi-tenancy or multi-vendors, integration with existing system or the existing network, then cost effective operational model. So all these are benefits of the L3 VPN. So what are the use cases of MPLS and L3 VPN in the corporate? The MPLS use cases, MPLS is widely utilized in various scenarios to enhance network efficiency and performance. It's used in traffic engineering, like you have to select or modify the paths in internet service provider ISP and allowing for optimized data routing. And also MPLS supports quality of service mechanism like the bandwidth management, the congestion management, crucial for delivering reliable VoIP, voice over internet protocol services. And also L3 VPN users are fast. L3 VPN offers a secure and efficient method for organizations to connect remote users, branch office, as we all know. And VPN does that. Any VPN is a secure communication. It is ideal for providing secure remote access to employees, and it ensures that sensitive information remains protected over the public networks. And L3 VPN can be used across the geographical boundary using VPN between the branch office and the head office. So these are the use cases of MPLS and VPN. And let me take you to the GNS3 console now. So here you can see that there are three routers. So just switch on the routers now. And now we'll configure the simple MPLS network. Only we'll give the IP and we'll enable the MPLS. That's the one we want to achieve. So let it boot. Interface pass 0 by 0, 1001, router OSPF, interface 0 by 0, shut, that is on 002, interface F1 by 0, interface F0 by 0, and give MPLS IP. That is the command you need. Only the MPLS IP if you give, show IP, MPLS show IP, and you give, let me see, MPLS, no, or show MPLS IP and binding. You can see that it is actually taking the two networks, but we have to actually go here, go to the interfaces of the router 2, and also you have to give MPLS IP interface F1 by 0 MPLS IP. And here if you give show MPLS IP binding, you can see this is taking the networks. And let me go here, zero, no shut, and MPLS IP and router OSPF1 network 0, show MPLS IP binding. So I think the OSPF network hasn't been started, or here we have added the OSPF any process. So let me wait for some time so that the OSPF process is started. Show IP root. So here also I think this should give the no shut command here. Interface F1 by 0, shut, and Also in the provider edge network also, you should actually have this thing. So you just go to the provider edge network here, the protocols. So protocol is OSPF, so it is definitely running the OSPF. So if I give show IP or show MPLS, rather MPLS, and you just give forwarding table. So your prefixes are actually here not coming, but it should come. Just I'm waiting for the OSPF process. So start. So it's 200, and here in the P network, show IP interface brief. So we had the basis, but it's already 1002 and 2001. That's personal 01002, the P router, but I think it is not taking correctly. So let me just restart it once more. So now I'm giving again the IP interface F0 by 0, no shut, IP address 1001.55.0.0.0. In the provider router, I'm checking with show IP interface brief, but in fast Ethernet 0 by 0, I should remove the IP first, no IP address, and you give IP address as 1002, and on F1 by 0, we address 2001.55.0.0.0. And on P1, show IP interface brief, no IP, interface F1 by 0, no shard, is 2002.5. The PE router console is showing. I've configured OSPF on PE1. Now on PE router, But for somehow it is retaining the previous session, it is 1002 and this PE router, but it should be the 1001 only. But what I'm saying, it is 1002 and 2001. It is showing the P router. What you can do, you can move to the router OSPF1 and you give the network as 1000.255, yeah, 0 and the 2 network. Is already given. So if I enable the labels on interface here on F1 by 0 MPLS IP, so this MPLS IP is enabled, but the thing is not that if I give the IP label here on F0 by 0, also MPLS IP and interface F1 by 0 also MPLS IP, and show MPLS forwarding table. So the labels should come in this forwarding table, the label and the outgoing interface, the prefix that should be there. But this router is actually, the console is not changing properly. So what you can see, I am in the PE1 router, but if I want to move to the P router, but the console is not changing. Maybe because of some issue, maybe in the it is actually running in the GNS VM. So maybe it requires a more lot of memory. So in that case, your console, so if I go to the PE1, so what I need to do, I need to configure the MPLS IP on the right interfaces that I've already done. But as I cannot enter the P router here, or you can see that it is not changing to the P2. I have restarted the routers, but it is, the console is not taking to this. Even if I shut down the console and I reconnect that, and again I connect to the console view, but it is coming to the PE1 and the PE router now. And in the P router, if you go to the console, but the P router console is not connected. So this router is actually not connected. So that is why even if you give show IP protocols, so the protocol is running, the OSP protocol is running, and that should be the enterprise protocol. But if you give show MPLS IP binding, then it is taking the network. It's taking the 2.0 network that it is routing, but the label swapping it is not achieved. So maybe these nodes that we have in this GNS3, so it requires, as we have seen, it is running in the GNS3 VM already, but in some cases we require more advanced VMs and the RAM, and in some cases we need to run it inside the ESXi. So in case of these routers using the MPLS, it sometimes gives some issue in the even in the GNS3 console. But we have understood that how we can give the configuration command on the MPLS, and you can give the MPLS IP on the interfaces, and also you can see the MPLS IP binding, that is the MPLS table, and you can also see the MPLS forwarding table that I've shown you, that is the LFIB that I was talking about, level forwarding information base. So I want to try this on your GNC console using maybe it requires a 16 or 32 GB RAM, and you take 2 or 3, even 4 nodes, and you just configure the same IPs. And definitely, if you run it inside the GNC VM, definitely I think they will swap and they will exchange the labels there. So this is the process to configure the very basic MPLS IPs on your router, and later on you can also add different functionalities to this MPLS. So this is about your MPLS and your L3 VPN that we have actually discussed. And also, as we know, the VPN GRU also that is not applicable in case of this MPLS. So in that case, first you have to configure the basic the MPLS IP, and then you have to configure VRF. That is also, again, it will take a lot of resource and CPU utilization, and then only you can go for this MPLS, because this MPLS is not a very basic topic that you can do on one workstation. There is some definitely limitation on this MPLS because it is the highest form of WAN technology you have. So you need to have a high resource for this, and you have to have a lot of nodes there connected, and only then you can see the entire approach in the MPLS. But I think it was clear to you how to enable the MPLS on the interfaces and what is the MPLS, because it's very important for your Cisco enterprise encore as well as the CCNS studies also. And if you're an aspirant for the certifications, I have a very good news for you, because I have a questionnaire that I have prepared, and there is a contest running on where I have prepared 10 questions, and I require every one of you to give correct answers, at least 8 correct answers out of 10 of this questionnaire. Because after that, if you give the correct answers of 8 questions, guess what? You'll be eligible for a certificate. So just think about that. If you get the certificate, that will be invaluable for your career certification. Because if you're a career aspirant for the CCN and CCNP, I urge every one of you to enroll right now for this course, because we also have another offer that if you enroll today, you receive flat 10% discount on a course. So you should grab this offer right now. And as a very senior network trainer, I personally take the CCNA, CCNP these courses. So definitely I will guide you for the certifications. So that is a very good opportunity for you. And as you know, CCNA, CCNP, they are the main parts certification. CCNA is the basic, and CCNP, they are the advanced certifications you have. And if you want to make a career in networking, because networking, as you know, that is a sky high career, its opportunity is sky high. So definitely, you should go for these networking certifications. So I thank you all for joining and watching this webinar once again. And I hope that you have got immense knowledge from this webinar, and you will be able to incorporate this knowledge in your enterprise networking and your certification as well. So that is it from me about the MPLS fundamentals and layer 3 VPN overview today. I'll come with some new topic next time. Till then, keep studying and bye.